Hi, my name is Daniel. In this video, I'm going to show you how Azure Dev Spaces can simplify your Kubernetes development. In this first part, let's take a look at how you can connect your local application to a Kubernetes cluster. As an example, let's take a scenario where you have three microservices talking to each other. A red one calling a green one calling a yellow one. As we're talking of Kubernetes, all of these services are actually running inside of AKS in containers or pods. And of course, all of that is running in the Azure cloud. Now, as a user, things are very simple. You just call some kind of public endpoint, and this call will be redirected to the red service. The red service will then call its backend service, which would be the green one, and the green one will forward its request to the yellow one, which will then return a result back to the green one, which will turn back a result to the red one, and that result will be brought back to the user. Let's say you are a developer in that scenario. In that scenario, you want to create a new part of the application, which then might replace the green service in the future. But for now, you just want to make sure that your application that you're developing actually works fine with its dependency, which would be the yellow service running in your cluster. To figure out if your application actually is doing what it is supposed to do, and if it plays nicely with all the other services within the cluster, at some point you have to deploy your application to the cluster. Typically, this means that you have to create a Docker file. You have to build that Docker file with Docker build, for example. Then you get an image, which you have to push to some kind of registry. And after that, you have to command Kubernetes to pull and use your image. Ideally, then your application is running within the cluster. And of course, if things don't work as expected, you want to debug it, and therefore you have to set up some kind of remote debugging. All of this can be pretty complicated. And of course, all of this takes a lot of time, especially if you're doing it over and over again. Now let's take a look at how Azure Dev Spaces helps. With Azure Dev Spaces, you install Dev Spaces tooling on your client machine. This is the machine where you're actually developing your software. Azure Dev Spaces tooling will modify the routing of your local machine in a way that for the application under development, it feels like it's integrated into the networking of the AKS cluster. That means outgoing requests from your application will be forwarded correctly with a correct name resolution for services in AKS while it stays on your local client machine. Let's take a look at what this looks like. I'm logged in here into my developer machine. I have already set up an AKS cluster, and I already installed some services and pods on it. Let's check those out. And we see that I have actually 3 pods running, pod A, B, and C. And I also have 3 services, A, B, and C. All of those services point to the pod behind it. So service A points to pod A, and service B points to pod B, and service C points to pod C. Now, as you can see, there are public IPs available for those services. I actually only need the first one to be really public. I just made the other ones public as well for debugging purposes, but we wouldn't need those public IPs for service B and service C in this specific scenario. So I will copy that IP address here, and we take a look at what we actually get if we call that. So let's open up a browser and put in that IP address, and we see we get a red website back. Now, this is basically the sample that I showed previously on the slides. This is my first service, which is red, and obviously the second one would be green, and the third one would be yellow. But this is really just for understanding the overall setup. We would not need to have service B or service C exposed via public IP. Now the interesting part is when I open up the service A again, the red one, I can call a specific API, which is called API Cascade. Now, if I hit API Cascade, if I hit that endpoint, you will see that I, as a user, am actually currently calling the red service, and the red service in the background is calling the green service, and the green service is actually calling the yellow service, which is then calling an endpoint on itself. Therefore, we get another yellow indicator here. And this kind of shows the flow of cascading API calls we see when we're hitting this endpoint. So this is pretty much exactly the scenario that I've shown in the slides. So now the interesting part is what would happen if we would be a developer who wants to work on that green service. In that scenario, we would have the code for that green service running on our local machine, and we would want to try out if it goes together nicely with the yellow service running in the cluster. Let's take a look at what that would look like. Now I'm here in Visual Studio Code, and I have basically the code open for my new version of Service B. And of course, I can run locally my Service B, and I can configure it via some environment variables. So I can say I want to set the color to purple. I want to say that this service should be listening to port 8081, and then I configure which endpoint this service will call in the backend. So this would be the service endpoint host, the service endpoint path, and the service endpoint port. So as I'm replacing service B, of course, my endpoint that I'm calling internally would be service C. So in the picture, this would be the yellow service that we're trying to call in the backend. And we are trying to call it on this path, and the port we're using is port 80. So now I have configured that, and all of that is, of course, running locally. So let's see what happens if we start this application. Of course, the application itself will start fine. I can call port 8081 in my browser, and you see that purple service running. It's purple because I configured it to be purple. However, if I now call that cascading API call, obviously this will not find anything. The problem is that now my server.js is actually running locally, and the endpoint I'm trying to target is actually a Kubernetes service with the name service C in the cluster. Therefore, obviously this would not work. And instead of, I just get a request error. What we can do here to help is that we use the Azure Dev Spaces feature to redirect local traffic towards the cluster. And that's pretty easy. In Visual Studio Code, I have the Dev Spaces extension installed, and this extension allows me to forward outgoing requests from my machine into the running Kubernetes cluster. So I just pick here Azure Dev Spaces, redirect a new Kubernetes pod to my machine. I can pick a namespace in which I want to be working afterwards. So this makes sure that services running in a specific namespace will be found from my local DNS. I just pick the default namespace because that's the namespace I've been working in all the time. As you can see here in the low right corner, there's something going on, and now ACDS exe is being called. On a Windows machine, this will result in a user account control prompt that will be open. And as you can see here, suddenly we get a new terminal, which is called ACDS Connect. We get the information that we are connected to the default namespace. And we also see a bunch of weird commands, all those set key value commands. With that, for this terminal, a bunch of environment variables has been created, and I can use within my application those environment variables. That's very interesting. However, it's even more interesting that I can now, of course, set my own environment variables within this session. And as long as I'm within this terminal and I start my application from within this terminal, all the outgoing requests will be redirected correctly towards the cluster. Let's take a look at what that would look like. Again, I configured my application to now have the purple color. I also configured it to listen to port 8081 as before, and then I configured the endpoint. The interesting part about the endpoint is that this is actually a name from a service running in Kubernetes. So it's something that is not known on my local machine. However, DevSpaces made sure that this can actually be resolved. So if I now start the server.js again, it's again listening on port 8081. I can call this service again, and now if I hit the API cascade endpoint, it will actually resolve, and you see the API calls are as expected. I, as a developer, are sitting on my local machine. I'm calling the local running purple service, and the backend request from the purple service is actually going into the cluster where the yellow service is running. All of that happens without affecting the routing of the regular services within the Kubernetes cluster. Therefore, if I now go back to the public IP address of my red service, I can still call this chain of cascading requests, and I will have the default behavior. That means, for me as a developer, I now have the chance to develop my new version of a specific service. I can test it in the context of a cluster. I can test if the backend services I call and I'm depending on, if those are playing nicely together with my version of the service. And the best thing is that all of that is running locally, which of course means that all kinds of debugging will just work out of the box. I can simply add a Node.js debugger as I'm working in Node.js because it's all running locally. There's no need to set up any kind of remote debugging because it's really all happening on my box. Additionally, at no point in time I had to Docker build, Docker push, or kubectl apply anything, because all of that is actually running without any kind of container right now. It's running on my box directly. I could, of course, take another step and say as soon as the software is good enough, I will package it into a container image. But during development, there's no need for that. It's all running locally, directly, natively on my box. Just as proof, let's see what debugging looks like. I still have the Node.js process running on my local machine. I go into Visual Studio Code and just say I want to attach by process ID. Then I pick the node process that I want to debug, and I see the debugger is attached. Now if I open up my browser again and I do a refresh, I will clearly run into a breakpoint here. We see that icon of Visual Studio Code blinks, and I see I ran into a breakpoint. I will continue here because that's kind of boring. Instead, let's go and see what happens if I hit the API cascade. And again, I run into a breakpoint, can follow through the chain of breakpoints and the steps one by one. If I want, with the regular commands from Visual Studio Code from my local debugger without any kind of remote debugging at all. All of that works while the regular behavior for people using the regular endpoint is totally unaffected. And of course, this will not lead to any kind of debugging experience for me because my purple service is not being affected as long as I do the regular call against the public endpoint here. Just as another hint, if you're running the whole thing on Windows, you might, on the one hand, get the user access control prompt that we've seen before, and also you might have to disable the branch cache service. So if you want to disable that, just go to your services application and then select the branch cache service. You see it here. Right-click it, go to properties, and say you want to set the startup type to disabled. And if it's still running, you have to make sure you stop it. So switch to disabled, say then you want to apply the setting that it is disabled, and then hit stop. If you do it the other way around, it might get started immediately again. And so make sure that this is set correctly whenever you start working with Azure Dev Spaces, when you want to have that local redirection experience. We've seen that Azure Dev Spaces tooling installed on your developer machine modifies the routing in a way that it feels like your local running application is integrated into the networking of the AKS cluster. It helps you call dependent services that are actually running in your AKS cluster in the cloud. There's no more need for Docker build or Docker push loops, and there's no need to actually command Kubernetes to run a specific workload, because the workload will continue running on your local machine during your development time. Debugging is something that is completely done locally with your local debugging tools. By getting rid of annoying and time-consuming tasks during your development time, this is how Azure Dev Spaces will help you improve your developer experience and speed you up. If you want to learn more about Azure Dev Spaces, check out these links. Thanks for your time.